A signal from deep space. A planet that defies all expectations. A race toward another star. What if everything we believed about the universe was on the brink of collapse? The James Webb Space Telescope, JWST, has uncovered revelations so astonishing they could rewrite the very definition of life. But is Proxima B truly a second Earth, or a dangerous mirage in the cosmic void? Often referred to as humanity's most advanced eye in the sky, the JWST has recently focused its powerful gaze on one of the most captivating exoplanets ever identified, Proxima B. Orbiting the red dwarf Proxima Centauri, this distant world has fascinated scientists and space enthusiasts alike since its discovery. But only now, with JWST's unprecedented imaging capabilities, are we beginning to unravel its deepest mysteries. And what we found is both thrilling and deeply unsettling. First detected in 2013, Proxima B remained a puzzle until JWST's arrival. Thanks to its ability to capture high-resolution infrared data, astronomers have, for the first time, peered into the planet's atmosphere, unveiling secrets long hidden from view. What they discovered has sparked both awe and anxiety. Proxima B orbits extremely close to its host star, just 7.3 million kilometers away, less than 5% of the distance between Earth and the Sun. It completes an orbit in just 11.2 Earth days. But this tight embrace comes with serious consequences. Proxima Centauri, being a red dwarf, is notorious for its volatile behavior, unleashing powerful solar flares that can drastically alter nearby planetary environments. Here's where things get even more astonishing. JWST has captured the clearest image of Proxima B to date, revealing surprising features. For starters, the planet is about 30% more massive than Earth, which translates into a stronger gravitational pull. But perhaps most alarming is the possibility that Proxima B is tidally locked, meaning one side always faces its star in perpetual daylight, while the other remains cloaked in eternal darkness. Imagine a planet where the sun never sets on one hemisphere, while the other is frozen in endless night. This extreme duality could create a harsh and unforgiving climate. The sunlit side might be scorched by unrelenting radiation, while the dark side becomes an icy wasteland. In such brutal conditions, could life truly take root? Yet the planet's orbital dynamics are just one challenge. JWST's latest data also shows that Proxima Centauri is even more active than once believed. Its intense magnetic fields produce solar flares so powerful they dwarf anything seen from our own sun. In April 2021, for example, a flare 100 times stronger than any ever recorded from the sun struck Proxima B, potentially enough to obliterate its atmosphere and leave the surface exposed to the deadly void of space. For many scientists, such extreme radiation levels and relentless flare activity cast serious doubt on the planet's habitability. Some argue that life as we know it couldn't survive there, but others believe that life has a way of adapting, even in the most hostile environments. Could alien organisms have evolved to withstand Proxima B's volatile conditions, or is the planet truly just a barren rock? As JWST continues to study this enigmatic world, more secrets are sure to emerge. But one thing is certain. Proxima B, located just 4.24 light-years from Earth, is far more complex and mysterious than we ever imagined. Could it hold the key to understanding the true boundaries of life in the universe? And if so, what does that mean for our ongoing quest to find life beyond Earth? Among the most shocking revelations so far is the state of Proxima B's atmosphere, or possibly its absence. The planet's close orbit and constant bombardment by high-energy particles from Proxima Centauri suggests that its atmosphere may have been stripped away, leaving it vulnerable to the relentless forces of space. Whatever the truth, one thing is clear. Our journey to understand Proxima B is just beginning, and its secrets may forever change the way we see our place in the cosmos. Over time, relentless bombardment by high-energy particles may have stripped away Proxima B's atmosphere, leaving it exposed and desolate, bare against the frigid vacuum of space. But here's where it gets intriguing. Some scientists believe the planet might still hold on to a thin veil of atmosphere, perhaps made up of heavier gases like carbon dioxide or nitrogen. If so, this could offer at least partial protection from the star's harsh radiation. Thanks to the James Webb Space Telescope, we now have a most detailed view yet of Proxima B's surface, and what it reveals is both fascinating and mysterious. The terrain appears rocky, somewhat Earth-like, yet vastly different. The side of the planet facing Proxima Centauri is likely scorched by relentless stellar heat, forming a desert-like wasteland. Meanwhile, the far side, shrouded in perpetual darkness, could be a frozen abyss, with temperatures plunging to extremes beyond anything we experience on Earth. But the most tantalizing possibility lies in the narrow twilight zone, the region where day transitions into night. This band of eternal dusk may host milder conditions, potentially allowing liquid water to exist. And where there's water, there might be life. Could this sliver of temperate terrain harbor a hidden oasis where life has defied the odds and taken root? Another startling revelation emerged from the study of potential water on Proxima B. If water exists, it might be locked in ice on the dark side or appear briefly as liquid in the twilight belt. However, what truly shocked scientists was the possibility of subsurface oceans, akin to those on Europa or Enceladus in our solar system. These oceans could be warmed by internal heat or tidal forces, resulting from the planet's close orbit to its star. If confirmed, such hidden seas would be prime targets in the search for extraterrestrial life. But the challenges are just as compelling. One major factor is Proxima Centauri's powerful magnetic field, which could interact with the planet's core to generate a protective magnetic field of its own, much like Earth's. This could help shield Proxima B's atmosphere from being completely stripped by solar winds. Yet, the situation is far from stable. The star's violent flares may periodically overwhelm the planet's defenses, triggering dramatic shifts in climate and surface conditions. These discoveries lead to more questions than answers. If Proxima B does possess a magnetic field, how strong is it? Can it truly shield the atmosphere? And if life exists, how has it adapted to such a volatile environment? Would it resemble Earth's extremophiles, organisms that thrive in our most unforgiving places? Or would it be something entirely alien? Proxima B remains a world of stark contrasts and extreme conditions, a planet that challenges our understanding of habitability. While the idea of a life-supporting world orbiting the closest star to our own is captivating, reality paints a harsher picture. The James Webb Space Telescope has unveiled the planet's daunting challenges in vivid detail. Perhaps the greatest obstacle is radiation. Proxima Centauri, a red dwarf star, is far more volatile than our sun. Its proximity to Proxima B means the planet is constantly bombarded by high-energy radiation, including solar flares up to 100 times more intense than those seen on Earth. These flares unleash dangerous bursts of ultraviolet and X-ray radiation that could be lethal to Earth-like life. In April 2021, a particularly massive flare was detected, strong enough to potentially obliterate any atmosphere that may have existed. This flare served as a chilling reminder of the hazards posed by red dwarf systems and cast a long shadow of doubt over the habitability of Proxima B. The chances of Proxima B being a haven for life appear slim. Constant bombardment by intense radiation would render its surface extremely hostile. Any surface water would quickly evaporate, and the rocky terrain would be scorched by relentless stellar heat. Meanwhile, the planet's dark side, shielded from direct radiation, would be plunged into freezing temperatures. This stark contrast between the searing day side and the frozen night side offers little hope for a stable, life-supporting environment. Yet despite these harsh conditions, the race to reach Proxima Centauri is gaining momentum. Although the mysterious signal from the system remains unexplained, the prospect of actually traveling there has shifted from science fiction to a real scientific pursuit. At the forefront of this bold initiative is Breakthrough Starshot, a visionary project backed by scientific luminaries like Stephen Hawking and investor Yuri Milner. The concept behind Starshot is as daring as it is revolutionary. Thousands of ultralight, stamp-sized spacecraft, called starships, will be launched into space, each equipped with cameras, sensors, and communication tools. These miniature explorers will be propelled by powerful ground-based lasers, accelerating them to an astonishing 20% of the speed of light. At that velocity, they could reach Proxima Centauri in just over 20 years, a mere blink on the cosmic scale. Once there, they would transmit invaluable data back to Earth, providing humanity with its first-ever close-up glimpse of Proxima B and the neighboring planets of the Alpha Centauri system. Though the technology is still in development, the strides made so far are nothing short of extraordinary. What once seemed like an unattainable dream may soon become a historic leap into the stars.